Okay, welcome to the next part. In this part, let me do some questions. Find the number of bond pairs, lone pairs, shape and hybridization of following. Okay, so I'll give you some examples. So you simply calculate the number of lone pairs, lone pairs, bond pairs, shape, hybridization, etc. Okay, fine. So let me start with the first example. That is, the example is ClF3. ClF3. Okay. So here what you have to find means you simply find the total valence electron. It's not total valency, total valence electron. Total valence electron. Valence electron of chlorine 7 into 1 plus valence electron of fluorine 7 into 3, and the total valence electron is 28. Once you obtain the total valence electron, you divide the total valence electron once by 8. Divide the total valence electron of that molecule once by 8. So you obtain 3 as the perfect divisor. So here will be 24, and you know how to divide. And the remainder is what? 0. Remainder is 0. If there is a remainder, then you divide it by 2. Divide it by 2 once. So your answer is 2. So this will represent the bond pair and this will represent the lone pair. Okay. So what you did? You find the total valence electron of that molecule and divide that total valence electron only once by 8. Okay, and find the perfect divisible or the perfect divisor of that 28, that is 24. Okay, where the quotient is 3 and the remainder is 4. If there is a remainder, then you divide that remainder once by 2. So here the remainder is 4, so I divide that remainder by 2 and the answer is 2. So what is the quotient? That is your bond pair. What is the remainder? The value which obtained after dividing the remainder by 2, that is the lone pair. So this molecule have 3 bond pair, 2 lone pair. So no need to find by heart that ClF3 have 3 bond pair, 2 lone pair. Okay, fine. You know, I already discussed that if 3 bond pair and 2 lone pair is there, then the molecule have T shape. Okay, and already said that you have to study that. Okay, we already discussed that in a table, right? So the shape is T shape. Here the total VSCP, equal to 3 plus 2. VSCP means bond pair plus lone pair, that is 5. So the hybridization, if the VSCP is 5, the hybridization is sp3d. So this molecule have an hybridization of sp3d. Is it okay? Move to the next. Next example, if I have XCF4, I'll give you random examples. We can discuss number of examples. If I have XCF4, fine. The total valence electron, xenon have a valence electron of 8, fluorine will have a valence electron of 7 into 4. Okay, so the total value will be 28 plus 8, that's equal 36. So you divide that 36 once by 8, then your quotient will be 4, and the 4 is in 32, where the remainder is 4, and divide that remainder once by 2, and your answer will be 2. So this is the lone pair, this is the bond pair. So this molecule have a bond pair of what? 4, a lone pair of 2. So the total VSCP 4 plus 2 6, hybridization sp3d2, 4 category, the 4 category, 4 bond pair, 2 lone pair. You have to study that table. This shape is said to be square planar. Square planar. I already discussed and I already said that that's very important. 3 bond pair, 2 lone pair. That's very important. You have to predict you should know how to predict the shape. Okay. So no need to by heart that these all details. You simply find the total valence electron. In order to find the total valence electron, you have to know the valence electron of each element. And in the first class, we already discussed the valence electron of each element. Okay. So everything is important. So if you know the total valence electron, and anyone can divide the total valence electron by 8. That's very easy. So you obtain the number of bond pair and lone pair. Number of bond pair, lone pair, once you add it, you obtain the total VSEP. Corresponding to the total VSEP, you can easily predict the hybridization. If the total VSEP is 6, then it requires 6 orbital like 1s3p 2d. It's very easy. And if you know the bond pair and lone pair, you should be able to predict the shape. And this is discussed in VSEP, VSEP theory, fine. So the next, that is I3 minus. I3 minus. What is the shape of I3 minus? What is the hybridization of I3 minus? The question like that. So find the total valence electron. Valence electron of iodine 7 into 3. And -1 means there is an additional electron. There is an additional electron. This is not valency. This is valence electron. So you have to add once minus is there. So +1. This -1 represents additional 1 valence electron. So +1. So the answer will be 22. And if you're 22, which divided with 8, 2, 16, what the remainder is 6, and your 6 on division with the 2, your answer is 3. So these are the bond pair and lone pair. These are the bond pair and lone pair. Ready? Is it okay? These are the bond pair and lone pair. So 2 bond pair, 3 lone pair. What is that category? That category, bond pair equal to 2, lone pair equal to 3. That category is linear. 2, 3 category, linear. That's very important. You should be able to predict the shape, and it is discussed in the previous class, which means in the section of valence shell electron pair repulsion pair. And the total is 2 plus 3. So VSEP is 5. VSEP 5 means the hybridization sp3d. Okay. Now the next, CO3 2 minus. Okay. Total valency. Valency of carbon 4 plus 2 into valence, it's not total valency, it's total valence electron. Valence electron of carbon 4, valence electron of oxygen 6. So this is actually 3 into 6. 3 into 6, or the number of valence electron 6 into 3 plus their additional 2 electron, so plus 2. Okay. In case of valency, in case of finding valency, this minus decreases 2 electron. Okay, but in case of valence electron, this increases 2 electron. In case of valency, -2 decreases the number of valency by 2. But in case of finding valence electron, you have to add that electron. Okay. So what is the total answer? The total answer is 24, I think. If the 24 is the answer, 24 divided by 8, that's perfect. So there is no remainder. If there is no remainder means there is no lone pair. So this is a category of 3, 0. The perfect geometry is there because there is no lone pair. And that perfect geometry is, 3, 0. You have to know the perfect geometry, that is trigonal planar. Okay. In your objective question, there is no need to draw the shape. Okay. You are able to predict the shape of this molecule, number of bond pairs, number of lone pairs, and hybridization like that. That's very important. So total is 3 plus 0. The total is 3. The total VSEP 3. So the hybridization require s and 2p orbital. So the hybridization is sp2. Okay. But actually here, according to VSEPR theory, here is 3 bond pair, but actually in case of CO3 minus, we all know that 4 bond pairs are there. Here actually 4 bond pair. 4 bond pair is there actually, because that's the limitation of VSEPR theory. VSEPR theory is not able to recognize whether it is a single bond or double bond. Here 3 bond pair means this is a bond pair, this is a bond pair, and this double bond is also treated as a bond pair, because that is a limitation of VSEPR theory. But actually if you are asked to find the total number of bond pairs, means you know how to draw the Lewis structure of this molecule. That is discussed in the first class. So you know how to draw the Lewis structure of this molecule. So simply draw the Lewis structure, then you obtain the actual bond pairs. And this is not the actual bond pairs. If multiple bonds are there, it is not counted here. This is simply the bond pair lone pair arrangement, or simply the total number of VSEP based on VSEPR theory. The actual number of bond pairs you only obtain from Lewis structure. Ready? Fine. And your next molecule, that is NH4 plus. NH4 plus. Listen. What is the total valence electron? Nitrogen, the valence electron 5. 5 into 1 plus. Hydrogen, there is only 1 electron, 1 into 4. Plus 1 means there is a loss of 1 electron. So what about the answer? The answer is 5 plus 4 minus 1, 8. This calculation is wrong. This calculation is wrong. Listen, that's a very important point for this trick. In chemical bonding, always hydrogen equivalent to halogens. Always hydrogens are equivalent to halogen. That means valence electron of hydrogen and halogen here equal to 7. That's a very important point. So in this trick, you have to supply the valence electron of hydrogen and halogen as 7. We already supply halogen as 7, but you have to supply hydrogen also as 7. Okay. So let's count like that. Total valence electron. Nitrogen 5. Hydrogen 7. 7 into 3. Plus an electron lost. Minus 1. So what is that answer? 26. So here the 26 is the answer. Ready? 26 is the answer. Fine. Now you can solve that. So divide 26 by 8. So here is 3, here is 24, the remainder is 2. So divide that remainder by 2, you obtain 1. So this is a category of, I think this is not actually 26, right? 5 minus 1, 4. 4 plus 21. Oh, there is a wrong. Here actually 4 hydrogens are there. So like this. 28 plus 5, 33 minus 1. Oh, this is actually 32. Okay. If this is 32, if this is 30, this is completely wrong. 32 divided by 8, your answer 4, remainder 32, 0. So 4 bond pair, 0 lone pair. So 4 bond pair is 4, lone pair is 0. So the shape is tetrahedral. Fine. Tetrahedral. You should know that. 4-0 category tetrahedral. Total number of VSEP 4. So hybridization sp3. Okay. If you have CCl4, fine. Tell me the category. Total valence electron. Carbon 4. 4 plus halogen 7. 7 into 4. Answer is 32. If that is 32, then your 32 divided by 8. 4, 32, 0. So again, 4 bond pair, 0 lone pair. Tetrahedral sp3 hybridization. Okay, fine. If you have PCl5, PCl5. Phosphorus, valence electron 5 plus chlorine 7 into 5, answer 40. And if you have 40 which on division with the 8, here 5, here 0, 0. So bond pair 5, lone pair 0. 5 bond pair, 0 lone pair. The shape is 5-0 category, trigonal bipyramidal. So the total 5 plus 0, 5. So hybridization sp3d. Okay. Now the next is SF4. Total valence electron, sulfur 6, fluorine 7 into 4. So that's equal 34. And your 34 divided by 8, 4, 32, 2, 2 on division with the 2, 1, 4, 1 is the category. 4, 1 is the category. 4, 1 category, 4 bond pairs, 1 lone pair. And the shape is said to be seesaw. The shape is known as seesaw. Okay. But the hybridization total 5 are there. So hybridization is sp3d. Okay. Next is NO2 plus. Total valence electron. Nitrogen 5, oxygen 6 into 2 plus a minus 1. Plus 1 means 1 electron dropped. So 4 plus 12, 16. You have 16 with the 8, 2. Hello. Okay. So remainder is 0. So the category 2, 0. 2 bond pair, 0 lone pair. So the geometry will be linear. Okay. 2 plus 0, 2. Hybridization will be sp. Okay. Next example, BeCl2. Total valence electron, beryllium 2, second group element, chlorine 7 into 2. So the total is 16. Once again the 16 divided by 8, 2, 16, remainder 0, 0 lone pair, 2 bond pair. So this is a category of 2 plus 0. Category of 2 and 0. So the shape is linear. 2, 0 linear. Hybridization sp. Okay. Next, BeCl3. Boron, valence electron 3 plus 7 into 3. So total 24. Over your 24 divided by 8, 3, 24, remainder 0. So the category 3, 0. 3, 0. So this is 3 and 0. 3 and 0 is trigonal planar. Ready? Trigonal planar. Hybridization will be sp2 is enough. Total 3, sp2. Okay. Next is H2O. Here hydrogen, the valence electron is 7. So 7 into 2 plus 6 into 1. So the answer is 20. About 20 divided by 8, 2, 16. Remainder 4 divided by 2. Answer is 2. So 2 bond pair, 2 lone pair. So this is a category of 2 and 2. 2 and 2 bend angular V shape. Right? Bend angular V shape. Total 2 plus 2, total 4 hybridization sp3. Okay. Next, ozone. total valence electron where oxygen is the category. So valence electron is 6, 6 into 3, so total is 8. Your 8 is 18 divided by 8, so 2, 16, 2 divided by 2 and so on. So category of 2 and 1. 2 and 1 is bend, V shape or angular, you know that. Total 3, so hybridization sp2. Okay, XCF6, total valence electron xenon 8 plus fluorine 7 into 6, 7 into 6 48, 48 plus 8 50, 50 divided by 8, that is 8, 48, remainder 2, 2 which divided by 2 and so on. I'm sorry, 50 divided by 48, 6 is actually right. This is 6. So 6 1 is the category, 6 and 1. 6 bond pair, 0, 1 lone pair. So this is distorted octahedral, right? 6 1 category is distorted octahedral. So total 6 plus 1, so the hybridization sp3d3. Okay. Next is IF5. Total valence electron, iodine 7, fluorine 7 into 5. So total 7 into 6, 42. And the 42 divided by 8 up to 45, 40, remainder 2, 2 divided by 2, answer 1. So 5 bond pair, 1 lone pair. So this is a category of 5 and 1. 5 and 1, the shape is square pyramidal. Total is sp3d. Hybridization is total 5 plus 1, 6. So sp3d2 is the hybridization. Okay, ready? Fine. The next is IF5 is over IF7. So total valence electron, iodine 7 plus fluorine 7, 7 into 7, total of 8 into 7, 56. 56 divided by 8. 56 divided by 8, here is 7, so 56, remainder 0. So 7 and 0 is the category. 7 and 0, total 7. 7 and 0 means pentagonal bipyramidal. Hybridization sp3d3. Okay, so F NO2 minus, total valence electron, nitrogen. What about the nitrogen? Nitrogen, that is 5 plus oxygen 6 into 2. Minus 1 means 1 electron extra. 6 into 3, 24. So 24 divided by 8, 24, remainder 0. So here is 3, 0. 3 and 0, that is trigonal planar. Hybridization sp2. Okay. Next is H3O plus. Total valence electron, hydrogen 7, 7 into 3 plus oxygen 6 plus 1 charge means minus 1 electron. So into 3, 21, 21 minus 1, 20, 20 plus 6, 26. And your 26 divided by 8, 3, 24, remainder 2, which divide to form 1, 3, 1, 3 and 1. The category is pyramidal shape, 3 plus 1, 4. So the hybridization sp3. Ready? Okay. So this is a case. Ready? I think every example is over. One more, methane. Carbon 4 4 plus 7 into 4. Hydrogen 7 here. 32. 32 divided by 8. 4. 32. 0. 4 0 category. 4 and 0. Tetrahedral. Tetrahedral. 4 plus 0. sp3 is the total hybridization. Okay. So I think now you are okay that how to find bond pairs, lone pairs, shape and hybridization of a given species. No need to by heart that. You simply know what is the total valence electron and divide it by 8, and if remainder is there, divide it by 2. Now you obtain the total bond pair and lone pair. If you know the number of bond pair and lone pair combination, then you should be able to predict the shape. Okay, that is already discussed in VSEP theory. And if you know the number of bond pair and lone pair, you simply add it, then you obtain the total VSEP. So corresponding to that VSEP, you can easily predict the hybridization. Okay. With one more example, I'll drop this. IF4 plus iodine 7 plus fluorine 7 into 4 plus 1 means electron dropped. 7 into 4 28 plus 6 34. 34 divided by 8. 4 32 remainder 2 divided by 2 divided by 2 4 4 1 4 1 the shape is seesaw. Seesaw. Total 4 plus 1 sp3d hybridization. Okay, ready? Fine. So that's all about the geometry shape of molecule. Now we want to discuss some bond parameters like bond length, bond energy, bond angle, and resonance, polarity of bond, dipole moment, Fajans rule, like that. Some small areas are there, followed by molecular orbital theory and hydrogen bonding. Okay.